So in the chapter where we're taking a look at stoichiometry, one of the things you need to keep in mind is this isn't scary. A lot of people look at even the term stoichiometry and get a little frightened. There's only one new thing you need to know in this chapter, and what that is how to deal with those coefficients from our balanced equation. Stoichiometry is simply just calculating from one substance into another one. So as we look at some examples, let's just look at the examples of a mole ratio. We're going to use for all of these, the example of turning nitrogen and hydrogen into ammonia. Okay, so there's our balanced equation. Make sure you know how to do that. Otherwise, you need to go back to how to write and balance equations. That's where you need to start and focus. You cannot do stoichiometry without knowing those skills. But in this problem, what we're going to see is how many moles of hydrogen are in 12 moles of ammonia. Well, I'm going to start with the label of 12 moles of ammonia, NH3, and I'm going to convert it into moles of hydrogen. I really don't care how many moles of nitrogen are needed in this problem. I'm just looking at, okay, from ammonia to hydrogen standpoint, what is my ratio? Well, that's what these coefficients really stand for. Every 2 moles of ammonia will be produced by 3 moles of hydrogen. Okay, so it's just a 3-to-2 ratio. If I were to just do this math real quick, 36 divided by 12, I'm going to end up with 18 moles of hydrogen. Okay, this is not a scary step. It's just a ratio of those. Make sure that you are canceling one label and getting into another one. That way you won't screw up your which number goes on top, which number goes on bottom. Never worry about those things. Just be looking at getting rid of labels. Now let's take a look at an example where we're just looking at particles. Remember, in our mole conversions, we have the mole here. This number is always 1. We can convert into mass. We can convert into particles, and we can convert into volume at STP. And in this chapter, we're going to always be at STP. I can go from moles to volume at STP using the number 22.4. When going to mass, we're going to use our formula mass. Just look on the periodic table for the individual masses. 1 mole is, and you just add it all up. Now, when we're going from moles to particles, we're going to use Avogadro's number. We're going to use 6.02 times 10 to the 23rd. Okay, so those are our conversions. Now, in this problem, we're going to take a look at how many molecules of ammonia do we get from reacting nitrogen, as much as we want, really, to 1.806 times 10 to the 24th molecules. Make sure you're labeling everything here. It's going to get really confusing for you real quick if you don't. Molecules of hydrogen. Now, I need to go from molecules of hydrogen into moles. The reason that I need to do that is I can jump from mole island here of one substance into moles of another. I cannot go particles of one thing into another particle. The mole itself is the conversion. It's the common currency that we use between any of these substances within our equation. So I've gotten rid of the label molecules of hydrogen. I've gotten it into moles of hydrogen. Now, I can go from moles of hydrogen into moles of ammonia, NH3. And since the problem is asking how many molecules of ammonia, now I can go from molecules of ammonia, NH3, into moles of ammonia into molecules of NH3. Now, moles have canceled. Moles of ammonia have canceled. Now I'm into molecules. So now I can go back, fill in my numbers. 1 mole of hydrogen is 6.02 times 10 to the 23rd molecules. Looking at my ratio, I have 2 moles of ammonia for every 3 moles of hydrogen. Now I look and I see, okay, moles of ammonia to 6.02 times 10 to the 23rd molecules. Okay, so actually this step and this step end up canceling, and I end up with 18.06 times 10 to the 24th times 2 divided by 3. Make sure your final answer has 4 significant figures. Okay, I'm not going to show what that actually totals. Not a big deal. It's more the process that we're looking at. Now, the last example we're going to see is going an example with mass. Okay, now we're going to bring in the nitrogen. I want to know how many grams of nitrogen needed to make 38.5 grams of ammonia, NH3. Okay, so I'm going to get rid of the label grams of ammonia, and I'm going to get it into moles. Remember, that's the common currency between any of these. Okay, moles of ammonia now into moles of what we need, which is nitrogen. And the problem is asking, again, how many grams? So I'm going to convert now moles of nitrogen into grams of nitrogen. Okay, now the problem is all set up. Grams have canceled, moles have canceled, moles of what I need is canceled. I'm left with grams, so I can fill in my numbers. 1 mole of ammonia, now 1 nitrogen, 3 hydrogen. Nitrogen is 14, hydrogen is 1, so that's going to be 3. That's going to be 14. This formula mass is 17. Looking at my balanced equation, this is a 1 in front, so I put 1 there. This is a 2 for my balanced equation. And now I'd say 1 mole of nitrogen. There's 2 nitrogens times 14. That equals 28. So 1 mole is 28 grams. Okay, so I just multiply straight across 38.5 times 1 times 1 times 28, divided by parentheses, 17 times 2 times 1, close my parentheses. You'll get an answer, and make sure it is in 3 significant figures. Okay, now that we've done all of that, let's take a look at how do we do volume. Okay, volume, we're only going to be looking at STP, and we can do our last problem with these conversions. I want to know how many liters of hydrogen needed to make 13 liters of ammonia. We're going to treat this as a gas, and we're at STP. Okay, so we have 13 liters of ammonia. Get rid of the label liters of ammonia, and let's get it into moles of ammonia. Now you'll see some shortcuts where they'll say, well, you're going liters of one thing to another, so you can just look at mole ratios. Don't fall into that trap. We're still holding true to what we learned before. We're going to get rid of the label liters of ammonia, get it into moles. Now I can get rid of the label moles of ammonia. Don't shortcut anything. Get it into moles of, in this case, we need no liters of hydrogen. So I'm going to go to moles of hydrogen, and now I can go moles of hydrogen into liters of hydrogen. Okay, now it's all sketched out. Moles of ammonia have canceled. Moles of hydrogen, I'm to the label I need. So I look and I say 1 mole is 22.4 liters of a gas at STP. I see that I have 3 moles of ammonia for every 2 moles of ammonia, or 3 moles of hydrogen for every 2 moles of ammonia, excuse me. And 1 mole of hydrogen has 22.4 liters. This ends up canceling with this. Okay, so it's still 13 times 3 is 39 divided by 2. 2 significant figures for your final answer, and you're done. Okay, so that's how you do just the basic conversions within stoichiometry. See, it's not hard. We're going to take a look at, in the next tutorial, we're going to take a look at limiting reagents. And essentially what that's saying is what happens when you have 2 different reactants. You're going to run out of one first. That's in the next tutorial.